Hi Math 206 students, I'm going to go over how to do section 7.2, the chi-square test of independence with Excel. So I took this table right here, and these are the data points right here, and I've put them over here in Excel. So let me pause. Okay, these two formulas I'm going to show you are going to work just as fine in, say, Google Docs. So what we need to know is the sum. So equals, and I just type in the formula sum. I say I need these cells. I close my parenthesis. I hit equal. If I come over here, come down to this corner, I can click and drag, and it drags the formula. I'm going to make those red just so I know that they're sums. Equals sum of, close my parenthesis. Again, I'm just going to click and drag. I can get a total, and again, I'll make these red. Now you notice how these were my observed values. So I can find the expected values, what I would expect if, let me just click back here, if attitude and gender were totally independent. Okay, so what I just need to do is just take my total for this column and multiply it by the total for the row of this cell, and then divide by the total I have altogether. Equals total times total divided by, so column total, row total, and then total equals, actually, let me just go over why this is going to have 2 degrees of freedom, because I know it has to equal this total subtract this number, subtract this number. Okay, I don't need to do the calculations anymore once I've got this down. And I also, I don't need to do these anymore either. I can just use subtraction equals the row total, subtract this calculated value, equals row total, subtract that value, equals row total, subtract this value. So this is why we're going to have 2 degrees of freedom, because I needed to calculate 2 values, but I could find the rest by subtraction. Now the chi-square statistic is going to be the observed minus expected squared divided by the expected values. Go ahead and make that bold. Oh, come on. Yes, you want to be bold. Bold. All right. So I just say equals, and I'm going to put in parentheses just like observed minus expected, close my parentheses. Use that caret to say square, divide by expected value. And here's what's nice is because I've got these set up, I can just click and drag and click and drag. So I've got all these values right here, and I sum them up equals the sum of all these numbers, close my parenthesis. This is the one I'm looking for, so I'm going to make it red and bold because this is my chi-square statistic right here. So just to show you here, I've got the numbers. Here's what your book says. We've got the numbers. You notice how they have observed minus expected, quantity squared divided by expected. They get 7.99. Ours would be rounding 7.99. I'm going to do one more example. In this case, we'd have 3 rows, minus 1 is 2, and 3 columns, minus 1 is 2. So I'd have 4 degrees of freedom with this. So let me go ahead and go to Excel. Okay, so I just put in those values. I'm just going to find my sums again. And I can click and drag. I'm just going to make those red. Equals sum of these. So I have column sum, and now these are my row sums. Make them red. This is our overall sum, I'll just go ahead and make it bold. Okay, so expected would equal column sum times row sum divided by overall total equals, oops, not that value. This value, row or column sum times row sum divided by overall total equals, column sum times row sum divided by overall total. Just making that bold. Okay, go through the same thing. So let me go ahead and pause. This is boring. Okay, I've got enough degrees of freedom here. Equals row or column, subtract value, equals row total, subtract value, and then this one I can just kind of click and drag. There, I've got my expected. Then I do my observed minus expected, just make sure it's squared, divided by what I expect. Okay, just make it bold. Equals, parenthesis, observed minus expected, parenthesis, squared, divided by what I expect. And I can just click and drag, equals the sum of all of these, close the parenthesis. Wow. Sorry, I had to pause and look at that because it's just such huge numbers. I don't know. And look at this row right here. This influence from the difference between observed and expected is so huge. I mean, 37 points. And look at this one, 27 right here. So let me just go back to the original data. This was agree. High school is higher than expected. College is lower than expected. Especially if we thought they were independent of agree, disagree, and don't know. So I can tell already that this chi-square value is just going to be huge, even with 4 degrees of freedom. So just come here to chi-square. I tell it 4 degrees of freedom. I say, okay, do a right tail test, and I was looking at, what, 97 something? Let's hit 97. Yeah, p-value is 0. If I look back at the previous example, the one where we had 2 degrees of freedom, the chi-square, let me just go ahead and put it in as 8. Just hit chi-square again. Oh, well, alright. Tell it 2 degrees of freedom, and I can just say right tail of, I'll just say 8. Oops. 8. Okay, well that p-value is actually on the chart, but again, we would definitely be rejecting the null hypothesis that there is no, that these two categories have nothing to do with each other. They're independent of each other. So that's how I would use chi-square to go ahead and work with section 7.2.